Okay, so it says name a radius. The radius of a circle is like halfway across from the center to the outside. So a radius here would be like PO. It could also be PQ or PR or RP or QP. That would be fine as well. It'll accept any of those. And then diameter is a line that goes all the way across the circle through the center. So that would be like RQ. You could also say QR. That would also be correct. Name a chord. A chord is a segment that hits the circle at 2 points, but it doesn't have to be through the center like diameter. So this would be an example of a chord. So in this picture, it would be like SN right here. Or you could say NS. If the length of PO is 4 units, okay, if PO is 4 units, so this length right here, what is the length of QR? Well, if this is 4 units, that would be the radius. So QR would be the diameter. We can do 4 times 2 to get 8. And then QR would have to be 8 units. So pretty simple one. If you haven't done that one on ALEKs, definitely get it done so you can get those points. Next. Okay, in this circle below, D is the center. It tells you that BAC is 115 degrees, and it shows that right there. The first one, give an inscribed angle. That came up on the vocabulary, but it actually comes up in tomorrow's lesson, so I'll quickly teach it. An inscribed angle is an angle that goes all the way across the circle like that. So if I was to name an inscribed angle here, I might name this one. So like BDE. Or you could say EDB, but when you name the angle, the vertex of the angle has to be the middle letter. Okay, give a minor arc. So we went over this yesterday. A minor arc, there's a lot of minor arcs, so minor arc would just be less than 180. So maybe arc BE, that would be fine. Give a semicircle. So semicircle would be like half of the circle, like around half of it. So maybe right here. So BCD. You could also say DCB. Or you could go around the other way and say BED. It doesn't matter. And then it says find the measure of arc BC right here. Well, if this central angle is 115, then BC right here would be 115 degrees as well. So 115 degrees. And then BCD, just trace that. BCD like this is a semicircle, so that would be 180 degrees. Again, make sure to practice that on ALEKs. They're pretty easy once you get the hang of it. It's just a matter of practicing. Okay, and then this one right here, it says the radius of the circle is 16 meters. It says that right there. What is the circumference? So circumference, you can look at the reference sheet. It's on the reference sheet, circle. Circumference is 2 pi r or pi times diameter. We've pretty much used this one the whole year. This one's the same thing because 2 times the radius would be the diameter. I guess it's whatever's comfortable to you. I'm going to stick with what we've been doing, which is just pi times diameter. It says to use 3.14 for pi and do not round. So I'm going to replace pi with 3.14. If the radius is 16, then the diameter would be double that, 16 times 2, which is 32. And so I just put in 32 for diameter. And then multiply these two numbers. 100.48 meters. And it's just meters because circumference is a distance around the circle, so that would be the appropriate unit. Okay, and then here it says, well, it's hard to see in this camera, but the circle below has a center O. It shows its dimensions. This says 50 degrees right in here. It wants to know the length of minor arc AB, so it wants arc length. This is something we haven't gotten to yet, so I'm going to explain it right now. So what arc length is, so yesterday we talked about the degrees of the arc. Now we're going to talk about the distance of that part of the arc. So to find that distance, you take the arc degrees, which is going to be 50, and put it over 360 degrees. So 360 degrees would be all the way around the circle. So it's like part over whole. And then you multiply that by circumference, which is pi times diameter. So circumference would be all the way around, and then we need part of that circumference to find this part. So the degrees would be 50 degrees over 360 times pi, and then diameter, it says the radius is 7, so diameter would be 14. So pi times 14, like that. Okay, now all we have to do is solve this and we have the answer. It says to leave the answer in terms of pi, so we're just not even going to have to worry about that. If it helps you, you can put this over 1 so you can see what to multiply with what. So when you multiply fractions, it's just this times this. 50 times 14 is 700. You leave pi as it is, and then 360 times 1 is just 360. And it will accept this as its answer. Of course, you could reduce it if you want to, but that is the answer, and it would just be in yards. To reduce this, let's say on an assessment you have to reduce it, you can actually use this calculator. Let's zoom out here. You can do 700 divided by 360 to get a decimal, and then you can use these fraction buttons. So I can change it from decimal to fraction using this. So that would be 1 and 17/18. If I need an improper fraction, I can just hit this, and it gives me the improper fraction. 35 over 18 pi yards. And that would work too. Okay, so I'm going to end my recording here. So what I want you to do